All right, here we go. How you guys doing out there? We are now on episode 4 here. I got my coffee. You can barely see. I'm totally yoked up on caffeine. Rah! You ready to go, Wayne?
That's right. I'm ready to go. Fired up.
Okay, I'm just kidding. We're going to do it totally calm today. It'll be totally nice.
Monotone. Keep it monotone.
Monotone, because we're talking about coding.
Yeah.
All right, let's jump right into it, guys. We already got a screen share here going. Oh, actually, before we jump into it, we always got to give a shout out. I'm going to give a shout out to this location right here, which is our Denver location. Go Denver Broncos! I'm a big Broncos fan. So,
hey,
Wayne, where are you at today?
I am in Pasadena, sunny Southern California. Loving it down here. So that's where I am today.
Home of a pretty awesome university, as I recall.
And we are Hansel Lin, founder and CEO of theCoderSchool. I'm Wayne Tang
today.
And hanging out. Actually, I always wanted to say, hey, I'm here. I'm Gretel. I'm with Hansel. I just always wanted to do that.
Oh, boo! I've never heard that joke. I've never heard that joke ever.
I know, exactly. But I've always wanted to introduce myself to that, when I'm next to you. But I never did it till now.
Let's jump right in today. So we already got our code screen up. I think you can see this weird looking donut that's flying in your face, but in a kind of a scary ghost that maybe threw it at you. So this is one of our Ghost Bomber games. I think, Wayne, didn't you do this for one of our books, or where did this come from?
Yeah, it's in the book. It's in our Scratch book. So if you actually, buy our Coding with Scratch book by us and Basher, you will see a snippet of it.
Little commercial plug for you guys right there. So here's what it looks like. I'm going to press play, and oh, you got fruit spot. Wayne, why don't you tell me what's going on? Do the color commentary.
Yeah, well, the ghost is yeah, I guess you're just it's kind of like the Fruit Ninja Crush, right? There's all kinds of things, donuts, fruits, and all those things coming at you, and you're throwing fireballs, right? You're
chopping these fruits and you're exploding them. And so we wanted to show you this game today because we are not going to build it. Today we're going to try to build something similar to it, but we're going to use JavaScript today. So for kids out there, just know that this particular AppStream is, I'm going to call it semi-intermediate. If you don't know coding, that's awesome. You do need to know how to type decently well, because there's going to be a decent amount of typing. Or if you'd like, just hit pause on the video a lot, and you can always go back a bit and type away and make sure you match what we have. But we are going to get into a type language today called JavaScript, and it should give you guys a pretty good view into what some really cool coding looks like and how much more time it takes to make something cool. We can't make this thing for you guys because it would take a really long time to make something that looks like this. Not going to fit in the AppStream today, but we're going to make something close, okay? So to do that, you guys, first open up your browser, and we are going to go to this thing called p5.js. And actually, this is the editor. I will start here.
P5.
P5 stands for, I'm not sure what it stands for, probably processing version 5 is my guess.
Yeah.
And then JS stands for JavaScript.org. So everybody go here, p5js.org, and you will see that this is a free something. Free is always good. And we want to click Start Creating with the P5 editor. That's what we're going to use today. You can, just like Scratch, you can actually create an account. I created one already, Hansel Lin, right here. You can, I'm sure if you guys see up here, there's probably like a join or something like that. If you guys want to join, you can and save your code. But here it is. So, all right, so we're going to start talking a little bit about how this works. So this here is the code over here. Now, this is essentially JavaScript, okay? It's not straight up JavaScript. It's not normal JavaScript. Last time we talked about what JavaScript does. Wayne, where does JavaScript run? Where will we find it running?
It is going to run in your browser. It is the language of the browser. So actually, if you watched our last app stream, we covered that a little bit. So this is good just to reinforce that.
That means if you have a browser and you start typing in JavaScript into a file for the browser to read, it would understand it. Just like, Wayne and I both understand English. If you talk to us in English, we'll understand it. If you talk to your browser with JavaScript, it'll understand it. If you type in Python, or if you type in Java, which is a totally different language, by the way, than JavaScript, if you type in other language, your browser is probably not going to understand it, at least not most of the time.
Right.
It's a whole separate segment. Anyway,
Kind of like me with Chinese. I'm probably not going to understand it. Hansel probably has a chance of it.
Only a couple of words, ni hao and ci suo
Ni
zai na.
hao. Yeah, I actually, if I was a browser, Chinese comes at me with ni hao, I'm on it.
You're on it. All right, so this is, I'll just show you guys real quick. You probably don't need to know this, but there's actually 3 files that are used here. Sketch.js is where the javascript.js, so JS for JavaScript, that's where the JavaScript is. Index.html, that's the actual browser file. So the browser is reading this file, index.html, which has a bunch of stuff in it. But it's saying, hey, go look at this sketch.js, and that's where our JavaScript is. So that's where we're going to start today. I'm just going to hide this stuff here. So the first thing I'm going to tell you is this thing, setup and draw, it is standard functions found inside a library that we're going to use called processing. Some of you may have heard of processing. It's a really cool visual arts kind of coding language meant to help you learn and make cool graphics. It doesn't come on every browser. It's what we call a library. So Wayne, I'm going to give you like 2 minutes, and then I'm going to cut you off.
Let's do it.
Tech talk.
That's right. Tech talk.
Tech talk on the library.
2-minute tech talk. TTT. 2 minutes. Well, so processing is a library, as Hansel said. It's a library that's very popularly used for both JavaScript and Python.
Popularly is not a word, FYI.
Yeah, that's right. I'll spell it. Oh, my 2 minutes is running out really fast now.
Yeah, hurry up, man.
Okay. So the libraries in code are not so dissimilar from an actual public library. So like the library that you go to, right? So you go to the public library to find out information about all these different topics or things that you want to learn about, right? And you find the book, and you can take that information in a book, and then you can use it. And so the code library is very similar in that there are all of these bits of code, routines and coding modules that have been written by, could be anybody, and they're all in this library for people to be able to use. And so, you know, not everybody knows everything about anything, and so you go to the library, and it's the same with the code. So coders may be brilliant, but they don't know how to code everything. And so a library can be just as useful as in a public library, where you can go and borrow these modules of code, which is like a book, say, of information, and you can use it. And then other people, the beauty is just like in a real library where they can be shared. Anybody in the world can, you know, use the same libraries. And that way it just enhances everybody's programs, right? So you're not all starting from scratch. You're actually starting with these pre-built things that are in the library.
That's right. So let's pretend that I'm out here and I want to check out a book. Oh, I don't know anything about cooking Chinese food. So I'm going to go in here and check out the recipe book, and now I have it, and now I can use it. In this case, what we're doing is I'm going to check this baby back in. And I'm going to check out the processing book. So by checking out a processing book out of the library, I'm going to have all these cool functions that I can run that I don't have to worry about. And processing, like I said, is a visual editor, is a visual code library. So it lets you draw circles and graphics and do all this stuff that's really, really cool. In fact, if you go, if we go back to the PS5 website, p5.js, sorry, website. If you go back to this, this and look at examples, there are some really, really cool stuff that you guys could play around with. But let's go ahead and start with a new blank sketch is what they call it. Comes with setup and draw, because that is what comes with processing. The way processing works, guys, this is very specific to processing, okay? The way processing works here is it will run setup one time when you start, and one time only, and that's the only time it runs it. But what it'll do with draw is everything inside these brackets will get run many, many times a second. And that's how a lot of video games actually are made. There's this loop that just keeps going over and over and over, and it keeps drawing and drawing and drawing. And by drawing all these different objects at different times, or sort of as time goes on, just like a movie, basically, it'll make it look like things are moving. And so you'll get an understanding of what we mean by that once we get going. So the first thing we want to show you here is setup. So I'm just going to run some, just a super easy setup right here. So I will create a canvas that is 600, 400. Canvas means, like any artist would know, it's your canvas. It's where you're going to draw. In this case, I'm just...
The 600, 400 is the width and height, right?
That's right. So 600 is the X, how wide it is. 400 is the height. So you press play and there it is. That's a 600Y. Can you see the whole thing, Wayne? Maybe, maybe not. Who knows?
I can. Yeah, it's just light gray, but you can see it. And I mean,
Yep.
just to point out the beauty of having, you know, that pre-function to create canvas, right? Otherwise, you would have had to code it to draw that whole square. All we really gave it was the hit height and width, and it does it all
That's right.
for you.
If you think back to Scratch, all of those blocks are actually, you can think of it as little functions that somebody made in a library. So you don't have to actually code it. You just drag it in. So in this case, we're just saying create canvas.
Yeah.
So create canvas, all that does is makes it gray. That's the default color. All right. So what we're going to do is we are going to, in the draw, I'm going to make it, I don't know why it says 220 here, but what we like to do is a quick, we like to use RGB. So RGB stands for, Wayne?
Red, green, and blue.
That's
so,
easy.
There you go. That's a mini tech talk right there. If you hear RGB, you actually know that it's the 3 different colors, red, green, and blue. And using the different combinations of those 3 colors, you can create other colors. Really?
So
and
it just so happens, ooh, there's a bug flying here. I'm going to kill it.
Smash it.
Got it. All right. So it just so happens that
it's at high altitude in Denver. Lots of insects.
Lots of these insects because there's not a lot of air up here.
Yeah.
All right. So this background happens that it'll take 3 what we call parameters. So basically, you can give it 3 numbers, and the 3 numbers stand for red, green, and blue. So who remembers their color wheel? If we give 0 red, 0 green, and 0 blue, and we mash it together in one color, what color would that be?
Color of a cloud, I think. Oh, really? I thought. Oh, backwards.
You got the opposite?
I thought the opposite. I thought 255.
There we go. It's black. So just to show you how this stuff works real quickly, we're gonna keep this background here, but what we're gonna do is we are going to start using some variables. So you guys hopefully know what a variable is. If you're kind of an intermediate coder, we're gonna just create a random variable. I'm gonna call it G. G for green. Actually, I'm gonna call it green. Green equals 0. I'm gonna start off with that. And instead of doing background 0, we're gonna do background green. And we're gonna increase green. Green equals green plus, I'm gonna say 5. So
Fair
what
enough.
it should do is it should start this with 0, 0, 0. Then it should run draw again and again, and then it should go 0, 5, 10, 15, 20, right?
Yeah.
So I'm just gonna press play. What's that?
Yeah. That's what it looks like to me.
That's what it looks like.
Multiples of 5 on the green.
This should show you multiple of 5, and this should show you that it keeps running draw and how fast it runs it.
Yeah.
No, it killed me. Was expecting number for parameter 1, 0, index.
It doesn't think that green is a number.
So Y does not think is the number. I don't know. Does it need 1 and 1? No. Green, green. Wait, why is that? Green equals green plus 5. What line? 30. So by the way, this is obviously a debug
phase. Debug phase.
Color was expecting a number for parameter number 1. Really? String instead. Oh, I thought it was a string. Why is it thinking it was a string?
Do we have to declare it as a integer?
I think it's strongly typed, but let's see. Nope. Maybe it just can't take a green.
Because that's a predefined. It's because green is predefined in its language.
Oh, that's right. It is predefined. You're right.
Yeah.
That's right. On the web, actually, the green and red and blue and all those things are actually predefined colors. Good call, Wayne.
Yeah.
So I can't use green as a variable name, so I can take this out. This just throws you off right here.
Good lesson to show them. Good lesson.
Good lesson. See, I knew that. Good test to pass. All right. So you guys saw, so I hit play. You guys probably saw that this thing goes from black to really bright green pretty quickly. And so it's calling draw, and so it's showing you each time that it's making it greener and greener, just like Wayne's shirt.
And your background, one of our colors.
And my background. And in fact, I'll slow it down for you guys. There's this there's this function that I know of, frame rate. It says how fast this bad boy runs and how fast it refreshes. Frame rate 10. Let's see how slowly that goes.
Oh, so check it.
Slowly turning super bright green.
Oh, that's neat. That's neat.
So we're going to use frame rate later on to show you guys to slow things down. For now, I'm going to take it out, but I want to remember it. So if I want to take it out without erasing it, what's the first thing you think of, Wade?
I think of commenting it out, like putting a pound in front of it, if that's the right language. But in JavaScript, is it 2 slashes? I've been doing a lot of more PHP or something.
So we, so you see how I laid out? If you do 2 slashes, commenting your code, there's 2 reasons to comment your code. One is if you just want to remove something temporarily and put it back later, you can just, comment it out or comment it back in. Commenting just means, hey, code, ignore everything after this on this line. But also very often what you want to do is comment for the reason it sounds like. Comment. You want to put a comment in there so you can read your code much easier. Sometimes code gets a little bit messy, so you really want to comment well. Very, very important for coding. And we'll do that here as we go.
Super important. And probably one of the most things that a lot of coders just don't do well because it's an afterthought, but it's really super important.
Yeah, yeah. So, all right, so we're going to get rid of this G thing. That was just to show you guys that this draw continues to draw stuff. We're going to make this just like we're going to make it a green screen. We do have to call the background every time so that it clears it. I guess I can show you guys why in a second as well. But here's what we're going to do. I'm going to draw a little circle. So the way you do it in processing is you do ellipse, and then you give it 4 parameters, is what you call it, 4 numbers. You give it 4 numbers. The 4 numbers are where it is on the x coordinate. Let's say, well, let's put it right in the middle. So where is it on the x coordinate? So 300 is half of 600. That's why it says right in the middle. I'm going to put it right in the middle for the y coordinate. What would that be, Wayne?
So 200.
Right. You're like a calculator. Mental
right
calculator.
In the middle of that box. Boom.
And then the last two arguments, the last 2 numbers, parameters, are how big this ellipse you want it, how wide and how tall. So we're just going to go 10 and 10. So if I do this, I will press play and...
So it'll probably be a circle, a little circle.
Tiny little circle right there. So now what can we do with the circle is we can actually make it move. I'll also do just a quick, tiny, random little JavaScript tech talk here. You notice how there's no semicolon here? Semicolons are famous for something that screws up Wayne and I all the time.
Oh,
if you
yeah.
get a semicolon, sometimes the code will bug out at you. In JavaScript, it's actually optional. It's optional because when the code runs, the browser actually knows to throw in a semicolon for you in a certain place if you don't have it. So I forget what it's called, it's probably called auto semicolon insertion, if I had to guess.
Yeah,
that's probably what it's called.
Yeah. I think you nailed it right there. I'm gonna Wikipedia that auto semicolon insertion.
All right, so here's what we're gonna do. We're gonna start x at 0, and we're gonna run this bad boy across the screen. So x equals x. Okay, so actually we're gonna give you another. What's the quickest way to add 1 to a variable in most languages, Wayne?
Just do a plus plus.
That's right, plus plus. So
the plus trick.
X equals x plus 1 is actually the same thing as saying x plus plus. And it's also the same thing, if you must know, as x plus equals 1. So there's 3 ways to say it. The shortest way is x plus plus. So we're just going to do that. That just adds 1 to x.
Yeah.
Okay? So now, if I run this right now, it's probably not going to do anything. Right? Because
it's going to blow up.
It's probably going to blow up just like a bomb. Boom. All right, so we are going to run, actually, let's just go ahead and change it. So we are going to say, instead of going 300, we're going to go to x. So that should start x is 0 over here way on the left. That should start this guy here and go all the way across the screen.
Yeah.
Before we do that, though, I'm going to take out this background because we've already drawn the background, right? Do we really need it? I'm going to comment it out, and let's see what happens. Whoa.
Whoa, it's
line
moving.
Behind it. That's weird. Why is that? It's because with the way this works, when it loops around to do another draw, it actually doesn't clear the screen. It just draws another one unless you tell it to clear the screen. That's why we want to do the black background every time. This is very common in processing. Every time you do a draw loop, first thing you do is clear the screen so that you can draw another whatever you're drawing. So now that we clear the screen, so background 0, 200, 0 means make the screen green and just green, nothing else on it. And then ellipse will draw something on it. So let's hit play. Ah, cool.
Sweet.
Now, smoothly moving across. Look how smooth that thing is. Very smooth.
Motoring across.
Like butter.
That is like butter.
So that's the easy way to get x straight across. Now what we're going to do is we are going to try to start emulating or kind of doing that Fruit Ninja game or the Ghost Bomber game. Little bit. We're going to start throwing this ball at you. Well, no, we're not.
Little bit. We're going to try to make it look like that game.
We're going to start with a little bit of physics first, step by step, and then we'll get there. And then it won't look anything like it. Something kind of like it. All right, so now that we get x, we're also going to do y. So let's start y equals, well, let's start at the middle of the screen instead of at the top. So y equals 0, or y equals 200, y plus plus. And of course, we're going to replace 200 with y. That means every time it'll be a little bit of a different number that it draws the ellipse at. So let's see what happens here. So now it's going diagonal, right? It's going 1 over, 1 down.
Yeah, so it was moving for x, and now it's moving for y.
That makes sense. So now, so what we want to do is we're going to do some physics emulation here for you guys, right? So there's a lot of games out there where balls are
physics
thrown,
alert, physics alert.
Physics alert, nerd alert, nerd alert. Put on your nerd glasses if you really need to. Wayne, you got your nerd glasses with you? You don't have nerd glasses.
Don't, I guess.
Where's my nerd glasses?
Yeah.
Oh, dang, I think my son stole my nerd glasses. Dang it. I don't know if I can nerd out now. Okay, so let's just step by step real quick. Instead of going x plus, we're going to do x minus. So if we do minus with a y, where's it going to go, Wayne?
Up.
Up instead of down.
Instead of down. Up instead of down.
Double check and make sure. We always want to double check.
I always want to double check because we could be wrong. We aren't wrong very often, but we could be wrong.
Actually, we're wrong pretty often.
We're wrong about 50-50. Okay, 50% of the time.
50% of the time, that's right.
1 out of 2.
That's right. And you know what? I forgot to comment. So see? I'm such a bad coder. So
there you go.
We want to write down why it is that we're doing things. So clear screen and make it green. So these double slashes in JavaScript means comment. So draw a circle. And then we'll say change x and y. Did I spell that right? No, change,
change
x and y values. All right, so now we're going to make this x and y. So the y, with the y going constantly up by 1 and x going constantly up by 1, it just kind of floats away, right? It seems like it's just floating out of here.
Yeah, it is.
Well, what we want to do now is do some physics. We're going to do some physics. So let's do a quick, super quick tech talk. Wayne, put the stopwatch on me. Ready?
All right, I'm doing it.
We're going to do a super quick tech talk. Let's see, new share. I'm going to share a whiteboard again, the library whiteboard. So Wayne, do you happen to, I don't know if you were a physics nerd back in the day. Any idea what 9.8 meters per second means?
Gravity? I don't
Yes! Good guess. That is actually Earth's gravity. So if you guys have done physics yet, I'm sure you know that number. If you haven't done it yet, then surprise your teacher and go 9.8 and see if she freaks out when you start taking physics. 9.8 meters, because scientists like to use meters, per second, because what it means is when you say meters per second, that's your speed, right? How fast something goes. So it goes every second, it goes 1 meter. But if you say meters per second, that's actually what they call acceleration. It means how much faster does something go. So in this case, 9.8 meters per second means if you put a person or a ball up in the air somewhere, and let's just say there's no air, and it starts falling towards the earth, it starts going at 9.8 meters per second, and every second after that, it goes 9.8 meters per second more. Does that make sense, or am I totally nerding out? I'm probably totally nerding out.
Totally nerding out, but it makes total sense.
Yeah, awesome. So let's say you throw a ball up in the air and you start the ball at 17.6 meters per second going upwards. So if I am going to start throwing a ball upwards, 1 second later, it's going to be 9.8 meters per second. That's how fast it'll be going. 1 second later, it's going to be going 0 because 9.8.
Should that be 19.6?
See, I'm only right half the time.
Yeah, that's right.
But
there you go.
That we didn't pre-plan this. That was just
at all. This is totally live. I mean, we're recording it.
That's right.
Is live. And we only take one take.
That's right. One take.
True. One take.
All right. So if you throw something up in there at 19.6 meters per second, 1 second later, it's going to be, can I even double click this? Yes. So 1 second later, it's going to be 9.8, right? And then after that, it's going to be 0. And then after that, it's going to be negative 9.8. And after that's going to be negative 19.6. So what I'm trying to say is that's how physics works in real life. And that's how we're going to code our little throwing game as well. But 9.8 is a good, interesting number for you guys to remember. Did I go over 2 minutes, Wayne? Did you keep track?
Oh, man, I blew it as a timekeeper.
Probably at
okay, but
now.
actually, good self-clock. Good self-clock. You're not much
right.
over.
I better stop labeling. Okay, physics lesson.
That was good.
So now you guys can forget everything I said because we're not going to do 9.8 here because it's too hard. So instead of doing 9.8, we're just going to do like 1 or 2. Or we're going to play with the number and see what works best. All right, so what we're going to do is, in the example I gave, I said that if you throw a ball up at 19.6 meters per second, that every second it slows down by 9.8, right? So we're gonna emulate that by saying we're gonna give it initial up speed, so that we can do a variable, and so that we can change it along as we go. So we're gonna, in this case, we can't do 9.8 or whatever because the pixels don't really match up. So we're gonna say the up speed, let's start it at, I don't know, whatever, 10. So that's basically, if you're hucking a ball straight up, that's how fast it's gonna go on the screen, 10 pixels.
10 up.
10 up, 10 up.
10 up.
And so with the gravity, what we wanna do is the gravity needs to change by, it needs to change by up speed, but negatively. So I'll show you guys what I mean. So y minus equals, which as you guys might remember is the same thing as y equals y minus. So y equals y minus up speed. So right now it's going to be 10. It's always going to be 10 because up speed is 10, right? So let's just run this real quick and see what happens. Well, it just flies right off the screen.
So
and
it's going to be 200, then 190, 180.
Right. Well, so it should be, yeah. But right now it's just, oh no, you're right. Yeah. So the y is, that's right. So what we wanted to do is 200. We want to slow down how much y changes. So y changes by 10. Next time we want to change it by 9, then by 8, by 7. Because again, that's how gravity works, right? In this case, gravity is basically 1, I guess, because we're going to change it by 1.
Yeah.
So every time we change a y, we're going to change up speed as well. So up speed, we're going to use the shortened notation here, minus equal 1. Or actually, we can just do minus, let's do minus equal 1. All right, so minus equal 1. So now what should it do? Now I think we're going to look like some physics action coming here at you. Let's try it. Whoa, see, did you guys see the ball? It kind of went up.
That was too fast. Yeah, I saw it go up, and it was pretty fast though.
All right, so let's slow it down with frame rate. So uncomment, and then we're gonna say frame rate, well, I guess 10 is probably fine. So very slow.
Yeah, look at that.
Dropping down.
That looks a lot like gravity. I mean, it looks like it.
It is totally like gravity. In fact, what we can do is we can use a variable if we want. So gravity, and we're gonna do it up here. Actually, we didn't talk about why we did the variables up here. Wayne, do we want to talk quickly about global versus, or how we keep this variable through?
Yeah, I mean, yeah. So he's putting the variables outside the function. I mean, the main reason is that right now that these variables could be used then in different functions. So the different functions would be able to see it. If you put it in below where he's saying function draw, then it's localized to just that function.
That's right. So that means every time, so if I were to put it in here, that means every time when it got done with the draw function, it would just forget it. So if I put like x equals 0 in here, when I get done with the draw function, it would actually forget it. But in this case, we needed to remember it every time we do the draw function.
Right.
Now JavaScript handles global variables a little bit differently than a lot of other languages. You don't have to call out that it's a global, variable. It just kind of does it automatically. So some other languages, you might have to say it's a global variable, but whatever. That's the reason why we put it out here, because we want to remember it every time we, in between our draw functions. Okay, so I put gravity in here as 1. So I guess if we run it, it should do pretty much the same thing. Yes.
Yeah.
So it's very close, which is a very kind of lame throw by, just kind of like a 90-year-old person or something.
Yeah.
So let's just have it jump a little bit further over at least. So x plus plus, instead of adding 1, let's add 5 to it. So we're going
Ooh,
across the
this
screen.
is gonna go. It's gonna throw. Oh.
Yeah. All right. Well, so here's what I'm gonna do. I'm gonna add 10.
Yeah,
and
I
then
think you could
speed it
boost
up,
it.
and then it should look like a ball flying across the screen. Whoa! Can you see that?
Oh yeah,
Too fast.
super fast, but I saw it. I can see it.
Okay. All right. So let's keep a frame rate of I think it's is it the higher the faster? Okay, there it goes.
There you go. That's nice.
There you go. So that looks just like somebody threw a ball, right?
Yeah. Pretty cool, actually.
Let's do Peyton Manning back in the day, because Peyton Manning fan.
Peyton Manning.
Location.
Woo! Touchdown.
Touchdown. That's almost all the way through to the end of the canvas there.
Yeah, that's a good throw.
So that's basic gravity for you. Pretty easy to sort of emulate gravity in your code. It kind of looks like real gravity. We're not using 9.8, but there you go. Oh, another awesome trivia question is with the 9.8. So Wayne, do you know this one is a good brain teaser to ask people. If you drop a bowling ball and you drop a tennis ball from the same height, which hits the ground first? Do you know that one?
Oh man, I used to know that.
It's a trick question.
The same.
They both hit it at the same exact time.
Yeah.
And the reason is because that 9.8 meters per second, that applies to everything. So if you drop a person, a ball, anything from a distance, it all goes at the same speed. There's a reason for it, which I won't go into.
Unless you're wearing a parachute.
Unless you're wearing a parachute, yeah. So there are exceptions because the airflow will slow you down. But if there was no air,
that's right.
Like theoretically, if there's no air, if you had a parachute, it wouldn't matter. You would just go flying straight down at.
Right, a parachute would go same speed.
That's right. The parachute would also go at the same speed. That's right, which is kind
of
air. Weird to think about. But yes,
really weird.
Great thing when you first take physics, tell that to your teacher and they will be totally surprised. It'll be one of the questions on your quizzes, I guarantee it.
You get bonus points, A+ for sure.
That's right. That's what these AppStreams are about, getting you some bonus points.
If you don't get an A+, just email Hansel.
That's right. Email me. Okay, so all right, so we did the gravity, so let's see. So gravity looks like that. Cool. All right, so that's how it looks when it goes across the screen. Now we're gonna add another axis. So there's two axes so far. Because we're on a computer screen, it's two-dimensional, right? Meaning it doesn't stick out at you. You can't it won't bonk me in the face.
Yeah.
So we're going to emulate a third dimension, meaning something that looks like it's coming at you, like that ghost bomber, right? It looked like the fruit was kind of flying at you. So because we can't have something stick out of the computer screen, what's the best way, Wayne, to emulate? Are you doing Cabbage
Patch? I think, yeah, Cabbage Patch, or I was emulating the 3D, but yeah, I think nice. It's the size. Like it's small back here, and as it gets close to the camera, see how big it is? But my fist did not change, but it's perspective.
That's right. So if you pretend my bald head is a ball, and I go, whoa!
Whoa, look at that! Oh, dude, that was pretty cool. Actually,
that's right.
That's pretty cool. We should just do that all day.
So your screen did not change. It's still two-dimensional, but it looked like I was coming right at you. So what we're going to do is we're going to use the size of the ball to make it look like we're throwing a ball at you. So here we go. So we are going to start X, instead of starting it at 0, which is the edge of the screen, we're going to start it right in the middle just to make it look, just so you could see it. So right in the middle is 300. 300. 300s. Okay, so let's see. Do we remember what these two numbers here are for? 10 and 10, Wayne. What are the
width and the height of the ellipse.
Ellipse, that's right.
Yeah,
the width and the height.
The ellipse.
That's right. So in order to make it bigger, we want the width and the height to change at the same rate to make it look like it's bigger. So we're going to do one more. Let's see. We're going to do one more variable. We're going to call it z-axis. Do I sound like
z-axis?
Z-axis.
Z-axis. It's your French accent. That's your French accent.
So if you guys think about X and Y axis, of course, X axis goes across like this. Y axis goes across like this. When you guys take 3D geometry, Z axis comes out of the computer screen right at you.
Ooh, all right,
so that's so when you deal with 3 dimensions, that's what it is. So that's why we're calling it Z here. So let's call that variable z. We're going to start it at 1, let's say, which means it'll be tiny. And what we're going to do is we're just going to say that z is essentially the same thing as size in our case with the code. So we're going to call it z and z width and z height. And then
I keep thinking that you're speaking French, Hansel.
I am, man.
Hey, Z width and Z height.
Z width and Z height.
Z height.
All right, so we are going to change x, y, and z values down here. Let's see. So x. So we're doing let's just do z. I don't know. Equals z plus equals. Let's just make it 5. Let's just see what this happens.
Oh,
what happens?
Wow. Yeah. How much bigger will that make it?
So that means every time it's going to draw a circle, and it's going to draw it a little bit bigger every time. Let's see. Well, it did not work.
It did not do that. Or even the frame rate. The frame rate must just be too fast for us to see it.
Whoa, that did not work. Okay. You know why it didn't work? It looks like I can see why it didn't work. Can you see why it didn't work?
Let's see here.
It's just a typo. You'll have to squint hard.
Oh, I can't see it. I need a double, triple debug face. I'm not seeing it.
All right. Yeah, it's actually pretty small in here. So it's because I did an equal plus, which doesn't work.
Oh, plus equal. Plus equal, baby.
Plus equal. Yeah. So let's hit the play button here. What's up?
Whoa.
So that looks like it's coming close to sort of at us. All right, so that's going off to the side. So instead of going off to the side, let's have it go not so fast off to the side. And remember, x, the change in x is actually what change.
Yeah. We got to change that less. Got to change that less.
Change that less. So I'll just do it just so it looks like it's moving a little bit. I'll do 5. Let's say. Let's see what happens. Whoosh! That looks like a
it's coming at me. Almost looks like you threw something at me, Hansel.
Yeah, and I'm gonna take off this frame rate so it comes at max speed. Let's see how it looks. Whoosh!
Oh, I like it. I like
Whoosh!
It.
That looks so smooth.
I almost feel like I got to dodge it. Almost.
Yeah, isn't that cool? That's how coding works. That's awesome. So now what we're gonna do is we're just going to we're gonna add a statement in here so that it'll just keep throwing balls. So it's not just one ball and then I have to keep hitting play again. So to do that, what are we going to do? So remember that it keeps calling draw over and over and over. So what we're going to do is we are going to when do we do it? Right after right after here, we are going to check to see
or for the heck of it.
Or for the heck of it. To see if we got beamed. All right. So with a 3D with a z-axis, it depends on how big that ball is. I mean, I don't know if it's a ping pong ball or if it's like a gigantic, bouncy ball or whatever. So we're just going to pick a number. What we're going to do is check to see the size of z. If z gets to be greater than, let's say, I don't know, 150.
Okay.
What we're going to do is we're just going to start over and have it throw it again. So in JavaScript, you need to add these brackets. Well, you mostly need to add these brackets. And what will happen is if this case is true, if z is greater than 150, it's going to do everything inside the brackets, okay? Nothing also outside, but everything inside, and then it's going to continue. If it's not true, then it's not going to do anything inside. So the best way, what is the best way to reset and start everything over and have it throw it again? It is, in fact, to reset to set the same variables over. So because we've been changing x, we've been changing y, we've been changing z. So we just want to set these guys back to what they were in the beginning. So I'm just going to do a copy and paste. Oops, now it looks terrible. So I'm just going to give some tabs here. So now we're going to set it back to where it was in the beginning. And I think, let's see, are we changing up speed? Yep.
Up speed and gravity.
Gravity, it turns out we never changed gravity during.
Oh, right.
Draw.
Actually, so you're right. No, good call.
Yeah, so the gravity stays the same all the time. It's always 1.
Got it.
And actually, we didn't mess with the gravity. We probably should in a little bit, but. So check to see if we got beamed. If we got beamed, that's about 150. That's about the size where it is right on your eyeball, I guess.
And
if you
start
get
over.
and it'll start over and throw you another one. Let's see if this works. Ah, cool. So we're
Nice.
repeatedly getting bean right in the nose here.
Like rapid fire.
Yeah, so that's a quick summary of, or a quick easy way to just throw a bunch of stuff at you. I'll show you, actually, let's play with gravity real quick, just to see if this does anything. So gravity, just like in real life, it's not 9.8, but it's 1. But if we have less gravity here, it should be, in theory, just like real life. So if we have, well, let's do more gravity. Let's do more gravity, because we can't get much less than 1. If we have more gravity, this thing looks like it's coming at you, but just kind of drop to the ground really fast.
It's gonna hit your feet. Yeah.
It actually looks like it feels like it's hitting my feet.
It does. It feels just like, it's definitely, if you were in the batter's box, you would want to hold off on that and you take your base.
Not a strike. That's not a strike.
All on balls. Yep.
Yeah, and actually you could turn this into a baseball game if you want.
It kind of looks like a pitch. Yeah. It looks very cool.
Let's do gravity like we're on the moon. Half.
Oh, yeah, where it's floating. It's going to float.
Woo!
I like it.
A little bit higher.
A little bit, yeah.
So we can even say if we have 0 gravity, then it should just fly out of the screen, right? Yeah, so then then it really beans you in the head. Then it's just like a laser.
I think it missed my head. It went over my head.
Good dodging skills. All right, so that's how you play with gravity. All right, so we're going to show you one other thing just to make this a little bit interesting, or 2 other things. One other thing to make it look a little bit interesting is it's a little bit lame to have this ball go at the same place every time. So what we're going to do is we're going to have x change this 5. So you remember that x plus equals 5 means how far to the right it moves. The bigger that number, the further right that ball gets thrown. We're going to make it a random number this time and have it thrown in different directions. So to do that in JavaScript, we use this thing called math.random. So I guess we can explain it to you really quickly, but well, actually, I'm sorry. Before I do that, I will show you one way to sort of debug this thing. In JavaScript, you guys have maybe seen this thing called console down below. That's where we had the error before. That's a place where you can see errors, among other things. So what you can do in JavaScript is you can do console.log to print something down there, basically, so you can see something. What we're going to do is do this thing where, and in this case, it's going to do it every time it does the draw. So we'll see a bunch of these. So we're going to do math.random. So in this case, math is what, Wayne? Do you know what would you call math in its tech talk that we did earlier today?
I would call it a library function.
It's a library. So random is the function. It's like a chapter inside your math, which is a library. So we're going to call it math.random. You got to put these, pretty sure you got to put these parentheses there. Let's see what it does. Bunch of numbers. So in JavaScript, you just have to know that what math.random does is it gives you a number from 0 to 1. Random number from 0 to 1. Now the hard part is we want to change that random number from 0 to 1 to be anywhere from -5 to +5. That's going to take some math thinking. If you guys want to pause right here and you want to challenge, what kind of math function would you put on this in order to change 0 to 1 to be anywhere from -5 to 5? So I will type it out and you guys can join me or not. First of all, I'm going to do floor, math.floor. So floor just means take whatever number this is here and and drop it down to the next whole number. So all of these would become 0. And I'm going to multiply this random number by not 5, but I'm going to multiply it by 10. Okay, so the floor of a random number times 10. Let's see what that does. It gives me a syntax error. That's what that does.
That's what that does.
I knew it. There's too many parentheses here. It's throwing me off. So this parentheses thing is
1, 2, 3. 1, 2,
pain
3.
in the butt. But you can see how most editors, you can see that if I go over this parentheses, you can see it finds the matching one, which is cool. So now that we got the matching one, what's it going to do? Okay, cool. So now I got whole numbers anywhere from 0 to 9, it looks like. That's what the floor does. It makes it a whole number. And times 10 makes it, multiply out. So it's up to 9, up to 10. So what we want to do is shift that number. So any number from 0 to 9, how would we make it from -5 to 5? We want to shift it over by 5.
Subtract from them.
That's right. That's right. Awesome. So 0 to 10, subtract
Subtract.
5. So
Yeah.
if you subtract 5 from that bad boy, what's it going to do? It should give us anything from -5 to +5, I hope. That looks like it. Yeah, something like that. All right, so let's hit stop. So we just wanted to show you, a lot of times when you have new code that you're playing with, you can, do something like a console log or something or whatnot, just to see what it does before you actually use it. Just easier that way. So what we're gonna do instead, I'm gonna take this, I'm gonna Command X, so that's on the Mac, that's cutting it out. I'm gonna delete that, and I'm gonna put it here instead of this 5. So math floor, math random. So what this means is every time it does a draw, it should change this. Ooh, is this gonna change this every time? Well, I guess we'll see. It's gonna change this, like, I don't know, maybe it'll like kind of come weaving in here at us.
Yeah.
Whoa, it just kind of squiggles.
Yeah, it's just like a knuckleball.
It's totally, yeah, that's kind of a cool knuckleball. So actually, that's not where I want to put it.
Yeah.
What we want to do is,
on the outside,
we want to change it only when you reset it. So we're going to say X direction equals, it started off at, well, yeah, I guess let's just start it off at 5. And we want to add, okay, so make sure you do a cut here. So you copy it into your clipboard. We're going to add X direction to it. So every time, right now, every time it's going to add 5. But once we get beamed in the head, we want to change the direction to be this random direction. So now, every time we get the beam in the head, it should start throwing it into a different direction, right? I hope. We've been wrong before, but
yeah, but I doubt we're wrong this time.
There you go. Now it looks a little bit fancier. Now it's throwing it in different places.
Now,
so
it's like a real major league pitcher, right? It's going to be hard to hit. You don't know where he's throwing.
That's right. And so we can even, you can play around, and I'm going to go, this is more like a minor league pitcher, or more like me. Now we're throwing it all over the place. Sometimes a couple of balls here. Whoa.
Oh, yeah. Whoa. You hit the umpire. You hit the umpire.
A couple of walks right here.
Yeah.
So, yep. Yeah. So you guys can play around with that. So one last thing we want to show you here is so how you can use the mouse to actually hit the ball, to actually knock it out. So if you think about the Ghost Bomber, what you can do is, when you mouse over a fruit, it blows it up. In this case, we're going to mouse over the fruit and change it red, just to show you guys what it kind of looks like and how to do it. And so it just so happens that we know that, here, I'm going to add the comment, check for mouse hitting ball. So what we want to do is we want to check whether the location of your cursor is inside that ball. And so it just so happens that like with Scratch, it's pretty easy because you can just say, is one sprite touching another sprite? With any other language, you have to do a little bit of math work, okay? So here's where the nerd glasses come on, and you got to math out for a little bit. In this case, though, it's a little bit easier because we know that processing has this function called distance, D-I-S-T. So I'm going to go if D-I-S-T. So I just happen to know that. If you guys want to look at all the other functions that processing has, which would be awesome to make more stuff on here, just Google it, processing functions. So distance, I also happen to know that mouse X is the location of your mouse. I just happen to know that. It's something I Googled before. It's not anything a coder normally knows. You just kind of Google it.
Everybody knows mouse X. What do you mean?
So we want to find the distance between mouse X and mouse Y, and then X and Y. So that mouse X and mouse Y is the location of your cursor of where your mouse is. And X and Y
center
is
of the ball. Center of the ball.
Center of the ball. So if that
center.
Distance, so that'll give us a distance. If that distance is less than, what's the size of the ball?
Z or
Z size.
Right? Z axis. Z axis. Z ball axis.
So Z, you guys remember that's the size of the ball because it's getting bigger and bigger. So if your mouse is within the size of that ball, then it means you hit it. So in this case, we're just going to change it to red just to show you guys real quick. And so remember, don't forget the bracket here. Changing it to red is basically, and again, this is something I just happen to know. You do fill, and then Wayne, what would the 3 numbers be for red? Pure red.
RGB. So I would go 255 because that's max. but you can go in 0, 0 for the other two colors. That's my
right.
thinking.
That's right. Good point, Wayne. 255 is the highest you can go in RGB. That's just a random thing that is something that most coders know.
Yeah, there
Kind
you
of.
go.
But also you can Google it because that's what people do. People Google everything. All right, so we're gonna make it red if you put your cursor under it. Let's see it. Boom!
Oh, boom. You're not
So
a
it turns
bad
red,
batter.
hey,
But
they're
it never
all
reset. It's not resetting.
Why doesn't it reset? Because the way processing works is once you set the fill color, every ellipse after that's gonna be the same color. So what we wanna do is if the distance is inside, we'll fill it red. If it's outside, using the else statement, we will fill it white. What color, what are the numbers for white, Wayne?
I'm guessing 255 across the board because 0, 0, 0 was black. So I got to go opposite.
That's right, because you guys remember when you mix every color of the rainbow, it is, well, actually it's black.
Yeah, exactly. That's why my
That's
original
what threw you
guess.
off.
That's what threw me off. See,
Okay,
I
so in
think
coding, it's the
logically.
opposite.
I think like a coder. Very logical.
In coding, it's the opposite. All right, so let's see what happens here. All right, so
Yeah.
So actually, once it flies out of me, it turns white again, which is kind of lame. All right, so I won't do it that way. I'm gonna, instead of the else here, I'm going to, oopsie, I'm gonna put the fill up here. So
When it resets.
is that gonna work? No, that's probably not the right place to put it because that's gonna change it to white every time.
Changing it to white every time.
So I wanted to, oh, I know. So what is the one place, where do we reset the throw?
Oh, after Z is greater than 150.
That's right. When we get bean, that's where we reset the throw. So as part of resetting the throw, we're also going to reset the color to white.
Let's do it there. Let's do it there.
Should work.
50-50 shot.
Yes, that should work. That does work.
Cool.
So this is along the lines of what the ghost thing does. So a lot more code to it to get to. So with processing, you can put images in there and you can have it rotate and you can do all kinds of cool stuff, but it's a lot more work. What I'm going to do is I'll hit stop here real quick. We got one last tech talk for you guys, which is math related. We love doing this because we feel like, you know, coding is not just about coding. It's certainly not just about copying what I just wrote down. That's not coding. For those of you guys doing it, you're not coding. Coding is about the math and the logic beneath it, right? And so what we always like to do is teach a little bit more math on why some of this code works. So a quick final tech talk on this distance. This is something that if you guys have taken geometry yet, you guys will know what we're talking about and you'll be like, oh, I didn't know that would ever be useful. Here's where it will be useful. So what we're gonna talk about is this function, distance between mouse X and mouse Y and X and Y. All right, we're gonna go back to the drawing board here and let's see if we can actually do it and actually make any sense of it. Let's see. Should I do this one, Wayne, or Leslie, do you want to do it?
Yeah.
All right.
Well, you can go ahead. I guess you have the chalk.
I got the chalk. All right, cool. So here's your XY axis. We're going to pretend that this is 0, 0. So what we want to do, or actually, we're going to pretend this is your X and your Y. So what we know is if you're trying to get the distance from here, what am I doing? From here to here. So let's say that you are, this is where your mouse is, and this is where the ball is. Oops. Not right there, but I will move it. Can't move it. Here we go. So let's say the ball is right here and the mouse is right here. What we want to do, I'm going to make it down here.
Yeah.
So in order to make that, so what we do have is we have the mouse's X position and the ball's X position and Y position. So that means if we subtract this height, wow, how should I do this? Sorry guys, it's getting a little complex. Wayne, you got my timer on me?
Yeah, we're about halfway there. So, you know, you just got to speed up the ball mouse trick here.
All right, so here's the mouse's Y and here's the ball's Y. Y is like, ball's Y is right here. So if you subtract this from this, which is mouse's Y minus ball's Y, and then mouse's X minus ball's X, you can get this distance, all right? Now, here's what we're gonna do. We're gonna use this equation called the Pythagorean Theorem. Wow, you say, that sounds like you're so smart, Hansel. But it turns out that that's something that you would learn in what middle school, maybe high school?
I think
Geometry.
so. Yeah.
You take geometry.
So, yeah. Once you take geometry, it's a really probably the most known or most used actually theorem.
Yeah. Who do we think invented the Pythagorean theorem? Probably
Mr.
a guy named
Pythagorean.
Pythagoras.
Yeah, I think so. The guy who started saying z-axis.
So what we're showing you here is when you have a line like this between here and here and you want to find this distance, as it turns out, this is a right triangle. So the way you show a right triangle in geometry is you put this little square here. So we know that this is a right triangle. So what this is if anybody knows the formula, Wayne, do you happen to know the formula off the top of your head?
I kind of do. It's the one that stuck, but it's a squared plus b squared equals c squared. So as long as you know those two the straight edges that make the right angle, as long as you know those lengths, you actually can know the distance between ball and mouse.
That's right. This is the formula. So square means multiply it by itself. So what is A, B, and C? In this case, it is, we have to do a lot of labeling here. I'm running way past my time, but I'm doing it anyway.
But it's worth it. This one's worth it. We'll run over for this one.
Because it's real math. It is legit math, folks. Oops, C. A, B, and C.
That's
so
C.
if you have A, which we do because we have this y minus the mouse y minus the ball y, and we have B, which we do because we have the mouse x minus the ball x, we can actually solve for C. So it's an equation that you can use. You guys probably may or may not have solved for it yet. One of the most common ones is 3 times 3 equals, or 3 times 3 plus 4 times 4 equals 5 times 5. That's one of the most common, I don't know, I guess triangles that you can have. So if we had A was 3 and B was 4, then we know C is always 5.
Yeah.
Right? So,
and that does add up, right? 3 times 3, 9 plus 16, 25.
25, that's right. And so this is a bit of math for you guys. That might have put you guys to sleep, I don't know, but hopefully you guys will learn it. And again, when you get to geometry, you'll be like, oh yeah, Pythagorean theorem. Now I know how to calculate a distance between 2 points. And you'll know why when you're coding a game, when you're being a game developer, you'll need to know things like Pythagorean theorem. You'll need to know sine, cosine, all this trigonometry stuff. So when you guys are taking math class, you'll know why you want to do it. If you're going to be a game developer, you're going to need to know a lot of that geometry and trigonometry and even some calculus.
Absolutely.
All right. So I don't know if we blew through our time here or not, but I think that is it. Wayne, do we got anything else?
I think that is it for, episode 4, I guess. Yeah. But who are we?
We are Hansel, founder and CEO of theCoderSchool, and you are?
I'm Wayne, COO of theCoderSchool, and this is AppStream, episode 4.
All right, and I'm going to end on throwing some bombs. Woo! Thanks for joining us, you guys. I hope you have fun
coding.
making your app.
Happy
Peace
coding.
out. Happy coding.